Today, we're going to talk about absolute value inequalities. To start off, first a little review. What does absolute value of a number or expression mean? The absolute value of a real number, let's call it x, is defined as mod of x is equals to x. X is cap positive of x. For x greater than or equal to 0 and negative of x for x less than 0. So for absolute of x or mod x equals to x for x greater than or equals to 0 and it is negative of x for x less than 0. So let's write these things a little bit more symbolically. So here mod x is written as positive of x for x greater than or equal to 0 and negative of x for x less than 0. So this looks like a lot of stuff, a lot of complicated stuff. What does it all mean? You can think of the absolute value of a real number as the answer to the question, how far does this real number lie from 0 on the real number line, or simply what's the distance between 0 and this particular number on the real number line. Let's look at a few examples. Absolute value of mod of positive 7 equals to 7. Absolute value of minus 7 equals 7. And absolute value of 0 equals 0. So here, these two things should give you a fair indicator of what the same distance from 0 on the real number line means. So let's look at some absolute value equalities. When solving an absolute value equation, there are always two cases to consider. In solving modulus of x equals to 8, there are two values of x that are solutions because the absolute value of both numbers is 8. Okay, so x equals plus 8 or x equals to minus 8. This is a equality. This is not an inequality. So let's move now on to what an absolute value inequality means. We only have one sense to deal with for an equation. We just say equals to. But when we have inequality, we'll have two directions. That is greater than or less than. In solving an absolute value inequality, we have to treat the two inequality senses, which is the greater than one represented by this symbol and the less than one by this symbol, separately. So let's look at one of the cases where for a real number, let's call it x, is modulus of x is less than a, where a is a non-negative real number. This means that all the values of x lie between minus a and plus a. Okay. Remember, we need the distance of x from 0 to be less than the value a. Okay. Where do we find such values on the real number line? Let's have a look at a visual representation of the real number line. So here we have a real number line and we have put minus a and plus a and we have 0. So when you say modulus of x or absolute value of x is less than a, that means x lies between minus a to plus a. So this is represented as minus a less than x less than a, which we saw the same which is represented on the real number line previously. So the solutions of modulus of x greater than a are the values of x that are less than minus a or greater than a. So when you have modulus of x is greater than a, the solutions are x less than minus a and x greater than a. Remember, we need the distance of x from 0 to be greater than the value a. So if you take this and 0, so a and a, negative a and a. So x less than negative a goes to this side of things, x greater than a goes to this side of things. So when we use the absolute symbol, we are looking at distance from the origin to the real number x. So that's why when there is a greater than sign and with an absolute sign, absolute or modulus, this translates to x less than a and x less than x greater than a. So this is how we represent it on the real number line. Symbolically, as I showed before, we write modulus f x greater than a as x less than minus a or x greater than a. Let's look at an example and try to see how to go about the same. Here, modulus of x minus 3 is less than 5. So, the first step is to take the negative side of things. So, mod x minus 3 will be greater than minus 5, right? So, when we look at the real number line, right? So, we have to look at stuff which are after minus 5. So, here we just take 3 on both sides and we are ending up with x is greater than minus 2. Let's look at the other part of the inequality which we will have to address. Here x minus 3 is less than 5 and you add 3 to both sides of the equation, it becomes x is less than 8. So the final answer is x lies between minus 2 and 8. So x is greater than minus 2 and x is less than 8. So let's look at one more alternate method. Here absolute of x minus 3 is less than 5. The two statements x minus 3 is greater than minus 5 and x minus 3 less than 5 can be written as a shortened triple inequality. So instead of solving it twice, we can just write it as a triple inequality. So it becomes that much more simpler to go ahead and solve the question. So let's see what the next steps are. So you just write it as a triplet and then add 3 on both sides and you end up with x is greater than minus 2 and less than 8. So let's look at choose a value of, these are things to remember, just go through the same when you are using the absolute value inequality. Absolute value problems that are less than have an AND solution and can be written as a triple inequality. Absolute value that are greater than have an OR solution and must be written as two separate inequalities. So let's look at one more example. 2x plus 1 absolute is greater than 9. So since it's greater, we have to use two inequalities. It's an OR. So this is the first part and this is the second solution. So x can either be less than 5 or x can be greater than 4. This concludes the session on absolute value inequality.